Hello, this is Mr. Win, and now we have lesson 10-3, geometric sequences in series. So just like arithmetic sequences, there's a formula to find the nth term of a geometric sequence. Here it is. You get the first term, a sub 1, times the common ratio r a certain number of times. To get the second term, you do the first term times r. To get the third term, you do the first term times r twice. So times r, then times r. Alright, there we have equivalent formula. In case they don't give you the first term, they give you a sub b. You just change the 1 to b. Alright, so first one example. 5 people see a picture on Instagram that they share to 5 of their friends. Those friends share to 5 of their friends, who then share to 5 more friends, and so on and so forth. Alright, how many people are sharing it on the 8th round? So, we're going to use this formula. A sub n is going to equal a sub 1 times r to the n minus 1. So we don't know how many people are in the last after the 8th round. But the first amount is 5, and our ratio, common ratio, is also 5 to the n, this 8 rounds, minus 1. So that, I'm going to go right here, is really a sub n, or a sub 8 really, equals 5 times 5 to the 7th power. You can type in your calculator, and you get your answer, a sub 8. Equals 390,625. 390,625. That's how many people are sharing it on after the 8th round. Alright, you can also find the explicit or direct equation by using the formula we did before. Let's write an equation for the nth term of each geometric sequence. So to do that, I'm going to write the formula. There's a sub n equals a sub 1 times r to the n minus 1 power. We need to find r. We have a sub 1, so that's nice. A sub 1 is 0.5. But to find r, the common ratio, you have to divide. Second term divided first term, well, that's 4. Multiply by 4. 0.5 times 4 is 2. 2 times 4 is 8. 8 times 4 is 32. Alright, so I fill it in. My answer is a sub n is 0.5 times r. I'll do like this. 4 to the n minus 1. Alright, we do the same thing here. We also work backwards, so let's try this. A sub n equals a sub 1 times r to the n minus 1. Well, we know a sub 4, so just a sub 4 equals a sub 1, which I'll find, times r to the 4 minus 1. Then what we know, a sub 4 is 5. 5 equals a sub 1 times r is 6. 4 minus 1 is 3. 6 cubed. Well, hopefully you know 6 to the 3rd power is 216 times a1. I'm going to divide. 5 over 216 is a1. Now I plug it back in the formula, and I'm done. So our final answer is a sub n equals 5 over 216 times 6 to the n minus 1 power. Instead of dot, you can put a parentheses, might look a little nicer. Alright, next. Like arithmetic means, there are also geometric means, the numbers between two non-consecutive terms of a geometric sequence. Common ratio r can be used to find those numbers. So find 3 geometric means between 2 and 1250. So we have 2, comma, blank, comma, blank, comma, blank, 3 numbers, 1250. So we're going to use a formula to find r. So a sub n is a sub 1 times r to the n minus 1. Oh, this is a sub 1, and this is a2, a3, a4, a5. A sub 5, there's 5 terms. Alright. A sub 5 equals a sub 1 times r to the 5 minus 1. We know a sub 5 is 1250. A sub 1 is 2 times r to the 4th power. If I divide by 2, I get 625 because r to the 4th power. I can 4th root both sides. And I get 5, but there's even roots, I'm going to have plus or minus 5 is r. Alright, once you have r, we can just use it. So let's see what happens. If I say if r equals positive 5, here's my pattern. 2 times 5 is 10, times 5 is 50, times 5 is 250, times 5 is 1250. Alright, that works. Between 2 and 1250 is 10, 50, and 250. What if r is negative 5? Let's see if that works. Alright, 2 times negative 5 is negative 10. Negative 10 times negative 5 is positive 50. Positive times negative 5 is negative 250. Negative 2 times negative 5 is positive 1250. So here there are two different things that work. I could argue negative, but there are two scenarios. So found three. Are three either these three or these three? Alright, we also have a geometric series. It's when you add up all the terms in the sequence. There's the formula. You can use either one. Notice r cannot equal 1 because that is a restriction. You can't have to divide by 0. So the only difference here is either you can use a1 times r to the n or an times r with no exponent, or exponent 1. But they're the same thing. So it depends what you have. If you have a1 and n, use the top. If you have a sub 1 and a sub n, use the bottom. Alright. Or you can just always use 1 by just finding the thing that's missing. Alright. So find the sum of geometric series. So our first example had 5 people sharing the Instagram picture to the 5 of their friends, who shared to 5 of their friends, and then 5 more, and so on. How many people have seen it after round 8? So we earlier answered how many people were sharing on round 8, but how many people looked at it total. So we're going to do the sum of a geometric series formula, S sub n, and let's use the ones that only needs a1. So a1 minus a sub 1, that's a sub 1, times r to the n, all over 1 minus r. If I fill in this stuff, the sum after 8 rounds, if you want to say that, is a sub 1 minus a sub 1 times r to the 8 over 1 minus r. Well, let's fill in the numbers. So a sub 1 is 5. So it is 5 minus 5 times r. They shared to 5 people to the 8th power over 1 minus 5. And that gets us 488,280 people. Alright, so 488,000 people see the picture. If we went back to our original example, remember 390,000 were sharing it at the very end. So those 390 from the last round, and the other 90-ish thousand come from the previous rounds. Alright, if we did the other formula, so notice I just did this top formula. Let's try this other formula. S of n equals a1 minus an of r over 1 minus r. So S of 8 equals, the first number is 5. I was plugging right away. A sub n, remember? Or a sub 8. And let's go back here. Is this number 390,625? 390,625. 390,625 times r over 1 minus r. See what happens. So I typed in the calculator and I get the same answer, 488,280 people. Alright, again, the formula is exactly the same. Just which one do you want to use? Do you want to find the last term, a sub n, or you just keep it a sub 1 times r to the n power? Alright, and with geometric series, we had single notation to make it easier to write, shorthand. We do the same thing for geometric series. So here, let's figure this out. Let's find the first term. I plug in 3. So we have 4 times 2 to the 3 minus 1. That is 4 times 2 to the second power. 2 squared is 4. 4 times 4. That is 16. We know a sub 1 equals 16. Alright, we could find the last term, but we don't have to. We just need a r. R is this thing in parentheses that we're multiplying. That's the thing with the exponent. So we know r equals 2. And we need n. Remember, n comes from the top minus the bottom plus 1. So n equals 10 minus 3 plus 1. So that is 7 plus 1 is 8. There are 8 terms. Because there's third number, fourth number, fifth, sixth, seventh, 9, 10. Those are the positions. Now this is 1, 2, 3, 4, 5, 6, 7, 8 different numbers, right? So it's 8 different spots. So make sure you know it's the top minus bottom plus 1. Alright, knowing those 3 things, I can fill in the first formula. S of n of geometric is a sub 1 minus a sub 1 times r to the n power over 1 minus r. Fill in what we know. So if you want S of 8, A of 1 we found was 16. Minus 16 times R is 2 to the n, which is 8, over 1 minus R, which is 2. That you type in the calculator, and your final answer is 4080. That's the sum of those 8 terms. All right, last example. You can also use a formula to work backwards. Find a sub 1 in a geometric series that has that sum, that n, and that r. So remember the same formula. S of n equals a sub 1 minus a1 times r to the n over 1 minus r. Let's fill in what we know. We know S of n is 13,116 equals a1 we're missing. But actually, I'm pulling a1 out. I'm going to do GCF. GCF a1, so that'll be 1 minus r to the n over 1 minus r. So I could do a lot of things. Let me plug in r first, make life easier. A sub 1, 1 minus r is 3. To the n power is 7 over 1 minus 3. I can simplify some things. 13116 equals a sub 1. That inside, if you put in the calculator, you get negative 2186. Negative 2186. Over the bottom is negative 2. I could multiply both sides by negative 2. Or actually, I could just reduce this right here. That simplifies. So let me go up here. So we're at 13,116 equals 1093a1. I divide by 1093. I get 12 equals a1. And we found the first term. All right, I'll leave y'all with this practice problem. All right, find the 8th term of that geometric sequence. There's the answer. Hope you can get it. See you in class. Thanks for watching. Bye.